Right. In the last video, you saw one solution for this problem with overn time and overn space. I'm now going to attempt a version where we have overn space. I have not done this solution before, so this would be maybe more realistic to a real interview. So I'm just going to reset this problem. And let's see. So we understood the problem in the first example. Now what we're going to do is we're not going to create any new strings while we do the comparison. And so what we need to do is we need to have two pointers. One that points to the current character of the version 1 string and one that points to the current position in our version 2 string that we use to compare the individual characters in both version strings. So I would say we start with, well, I1, I2 is equal to 0, so that's where we start. And so what do we have to do here? Let's see. So if we start comparing, let's start with here. If we start comparing these things, so the first thing that we should do, well, I'm just going to create a while loop for now, and maybe we will modify the condition for the while loop in a little bit. But let's just say we are in a while loop. So we have to check if the characters of the first version string at the position I1 is the same as the character of the second version string at position I2. Let's just start with that. So that is version 1 string at that position, and for the second character we have version 2. So now if we have C1 is equal to C2, we could just advance both pointers, right? But we have to now take care of things like leading zeros, or is the position of these pointers, are they already beyond the length of the version string, which means we would have to fill in the zeros, right? Or pretend that we're reading zeros. So, and we also have to identify when we run into a dot. Right. So this is going to be a little bit tricky. I'm wondering what we should look at first. Should we first try to deal with the or maybe we could design ourselves a helper function that identifies when the next dot is due. Right? So we could have a helper function that only compares the revision numbers up until the next dot. And then we just call that function repeatedly until we've reached the end of both version strings. So maybe we should have a little helper function. So we could say compare the next revision, and we could have we could just pass in the indices, right? And what we would do then is we would, in our loop, we would do something like this. We get the comparison result of the next revision. And if it's not 0, we're going to return it. Because that means that we found a difference in the revision, in one of the revision numbers in these two strings. So we could start like that. While, yes, and now we have to modify our while loop. So for 1, we have to actually get our new pointers back from our revision string, and we have to check while, let's see, I1 is smaller. Well, one of the two pointers has to be smaller than the length of its corresponding version string, right? That is the condition, so we need to put that into code. While I1 is smaller than, smaller equal, well, actually smaller than the length of its version string, or I2 is smaller of the length of its version string. So yes. And our return here should be I1, I2. So we don't know yet what we get, but yes. So we need to fill in now this comparison logic. And what I've done now is I've modularized the problem a little bit, right? Because the problem looked too complex to tackle at once in one shot. So I'm trying to make it easier for myself to break it down into its components. And so now we have different cases, right? So we can have the case where I1 has already reached the length of its string. We can have the case where I2 has reached the end of a string. But we won't have the case where both have reached the end of their string, because if they have both reached it, it should have been caught in the while loop down here. So maybe the next step to simplify this problem is to really look at the different cases. So if we have, if I1 is larger or equal the length of its version string, this would be one case, right? And you could write if and I2 is smaller, just to make it clear. You don't really have to check this, but this makes this clear what is this case. And so it's going to be case 1. And the other case would be the opposite, right? So, and I2 is larger. And well, we could also have a third case. And the third case would be where both of them are, well, both indices have not reached the end of their version strings. So those are kind of the three cases we have to deal with. The fourth case is here. This is that. Okay. So in these cases, first case, we have to do pretend that we're appending zeros here. And in the last case, we have to do a direct comparison. So I would say could have another little helper function that advances an index such that it points to a non-leading zero after the function. Because we know that when we enter the compare next revision function, we're always at the start of the next revision substring in our version string. So yeah, let's build a little helper function. Skip leading zeros. And we just call this index and the string s. Right. And we'll fill in this in a second. Let's see. And we could actually call this, well, we could call this here at this point. We could call it right here to skip the leading zeros. Or we could call it here in this function. I'm going to call it here just to keep the logic a little bit more concise. So we'd say I1 equals skip leading zeros, I1, and then version 1. And we do the same for the second index. And we need to remember that I1 or I2 could already be beyond the length of their string. So if idx larger or equal than the length of the string that we pass in, we're just going to return it. We're just going to return the index unmodified, right? That's the first case. The second one is if idx is equal to the length of the string minus 1. Remember, indices in Python are zero-based. So if you have a string of length 3, if the index points at 2, that points to the last character of that string. So in that case, where we have only one character left in the string, it can't be a leading 0. So we're also going to return the index unmodified. So now we know that we can always look at position idx in the string and in position idx plus 1, because we know now that the string s has at least the length of 2. So we are going to have a little while loop here. While idx is smaller than the length of the string, minus 1, and the second condition to advance the index is that s at position idx is equal to 0. In that case, we're going to advance the index by 1. Otherwise, yeah, we're going to stop. So, yeah. We could merge these two into one if condition, but I wrote them out explicitly now, maybe just for clarity. End of string, idx points at last char of string. Those are the two cases. Advance idx while until it points to the last character or a non-zero character. Yes, so that's basically what that does. And let's see. Now, if you think about it, you could probably delete those two, because the while condition already covers both of these cases. So while will never go beyond pointing at the last character of the string. So if idx is smaller than the length of the string minus 1, that means it's not pointing yet at the end. If it's equal to that, then it points exactly to the last character on the string. But if it's smaller and at position 0, and at its position it has a 0, then we want to advance, right? So that means we can delete those other two requirements, and it's good enough. It gives us everything that we need already. So yeah, nice simplification there. But it helps sometimes to write things out. And by the way, you don't have to write comments in the code in an interview, but it's helpful sometimes just for yourself. Depending on your interview form, you may find that you're not 100%, and especially then it helps to annotate your code and just to keep your mind sharp, and just to remind you what you did on different parts of the code. It's really helpful, and you can always clean up your comments later if you want. What I would do is, okay, so now I think I have a working algorithm, blah blah blah, and now for production I would of course remove all of these comments. The code should be self-explanatory. I just wrote it to help me think a little bit better, right? If you say something like that, then they fully understand, and they don't think that you write code that is so verbose with comments. Anyway, so back to the problem. So we now removed our leading zeros. That's great. So now we can start comparing the versions. So the revisions, sorry. So we know that a 10 is larger than a 2. So if we start to compare the, how do you say, by character, you'll find that 2 is larger than 1, but this would give us the wrong result, because then we would think that version 1 is larger than version 2, but the opposite is the case. So what can we do here? Well, we could count how long the 2 revisions are, right? So we could, for example, say, we could fetch the position of the next dot, and then that tells us immediately how long, well, how large these numbers are, or what magnitudes they are. We know that this would have 2 digits, and this has 1 digit, so obviously version 2 is going to be larger, and we would return the correct value. So that's one thing we could do. Another thing that we could try is, now we said we want to use constant space, but we could also, build this number up until we run into the next dot. So we could say, what should we do? Well, I said let's do it in constant space. So in this case, let's not build up the number to compare them then. So what I will do is I'll add another little helper function. To get the length of the revision string, substring. Length of revision substring length. And here we basically iterate over the characters until the next dot. But because we're only doing this once for every revision, I can't pronounce this, revision substring, the overall runtime complexity will still be O of n, right? So, okay, yeah, let's do that. So while the index is smaller than length of the string, and the position is not a dot, right? While that is the case, we will do this. And yeah, so that should be it. So we want to advance our index that we pass in until we run into a dot or reach the end of the string. That tells us how long that thing is. Now another thing is, actually, we should maybe rename this and say get revision substring of revision magnitude or digits, substring length. I was thinking you could rename it to return the magnitude of the revision substring, but length is fine, I guess. Now, there's a special case where we have to append the zeros in case they are missing. So if the length is 0, in that case, we should return 1, right? If this condition never occurs, or well, if this condition prevents us from entering the while loop, we still want to return 1, because we know it's going to be exactly 0. So that would be 1 digit. Yeah, and I guess we could do this. Return the maximum between the length actually found and 1 if we assume that we want to place a 0. Yeah, I think that should do that. Okay, so we have the skipping of leading zeros. We have the revision substring length. By the way, this solution is taking very, very long. So in an interview, you want to be much faster than I am currently. But I think it's good for illustrative purposes. Okay, so back to our case. We know that we can extract a revision substring from both of our version numbers, so that is case 3. And in this case, we could probably, we now need to compare the digits, right? So what we'll do is, let's see, I1 version 1. And I'll just call this L1. So we're going to get that. And now we just do compare. The first comparison would be if they are unequal, right? If L1 smaller than L2, return. Now we know that L1 has fewer digits than the second one. The first revision substring has fewer digits than the second one. And that is our first example. So we return -1. If we do it in the other direction, we return +1. And if they're the same, we actually have to do a character by character comparison. And by the way, this is just the CMP, so we also have to return our new position indices. So we also have to do something here. So we have to advance actually our pointers, and we should be able to do this with I1 plus L1, I2 plus L2. And since we expect a dot, we have to also jump over the dot. That is the separator. And if we're already over the end of the string, it doesn't really matter. So that's exactly what we do here. And otherwise, yes, we will do this. We will return, let's see. I don't like all these indices here. So I'm just gonna write it like this. Okay, I1 next, I2 next. Okay, cool. So now for IDX in range L1. L1 and L2 are the same, right? That's the third case. And now we look at version 1. Actually, yeah, we don't really have to do that. Well, yeah, let's do that. IDX, just looking for the right naming for the variable. I1 plus shift, I don't know what the good name is for that. If that is smaller than the thing in C2, in version 2, then we're going to return -1. To make that more readable, we could just say C1, C2 is that. So we're extracting the character from the version strings into this variable, is C1 smaller than C2. And now we're comparing characters, but since they are ordered, wait, how's the order in the ASCII code? Is the 0 before the 1 or after? I'm not 100% sure. I think it should work without int. I'm just to be sure, I'm just gonna add int. Lexicographically comparing the digits from 0 to 9, I think that should work, but just to be safe, I'm just going to do this. So if that is the case, return -1, otherwise we return +1, and at the very end of it, nothing happened. So we're just going to return 0 for the comparison, and of course the position for the next index. Okay. So now you see a shitload of code and a lot of time that we actually invested into this. Yes, and I think we can delete that. Now we have the other two cases, and I suspect there's a nice way of making them work well with this case. So we would also call get the length of the revision substring. So I guess we can move that up here because we're going to need that information anyways. And yes, the only difference now between these cases is that we must assume a 0 in the case of where one of them has no revision substring. Let me think for a second. So here we assume that we can still extract the revision from each. So we get the length. So even if so I think we can also move this length comparison up here because we've already taken care of that length returns 1 in case there's a 0. Right? So we can actually move the length comparison also up here and the return. Nice. So the last bit is that we need to deal with the case that I1 or I2 are larger than its version string. So if I split this up, if I say C1 is equal blah blah blah, and the C2 character is blah blah blah, maybe I should just have a conditional check here. And then we need to change this. So if I change this to the maximum, well, actually, no, because if we didn't return here, that means the length is the same, right? So we don't have to do maximum of the length. So let me just move this to this level. And so now we just have to check if we can actually access that index. And if we can't, that means the character will just be a 0, right? Yeah, I think that's the only thing that we have to do. So it's 0 if I1 plus shift is larger than version 1. Otherwise, we're going to use the int value. So, oh, this is actually also the int value. So we set C1 to 0 if the index that we're trying to access is larger than, or is basically out of bounds for the string. Same here. And let's see. Yeah, let's see. We should probably change this to make it a little bit easier. So I'm just going to write here IDX, and we're going to, no, actually we can't, because the offset is dependent on what values of I1 and I2 are. So I'm just going to put that here, else version 2. Okay. Yeah, I think that's it. And then now we can eliminate that block. And we should be good to go. I think we now have all the bits and pieces in place. And normally I'd go through a debug one more time, but I'm kind of tired. So I'm just going to click run and pray that it works. Okay, so we have some error. Let's see. Aha, so we run into a problem. So this can happen in an interview too, and use this as an opportunity to showcase your debugging skills. Yeah, so what we see here is we're running actually into a dot. So when we try to access this thing, we're trying to convert a dot into an int value. So putting it as an int actually helped us, right? Length L1, L2. Okay. Off by one errors are really annoying. So how could this happen? So there are several ways to debug this. Either you go through your mental debugger, or you start adding debugging output, which can also get super messy really quickly. Does it show me which example? Yeah, this one. Okay. So it's failing on this example. Did we make an error where we compute the length of the substrings? So if I were to add print statements, I would actually print the substring from I to I plus L. So maybe we should do that. Let's just do that for fun. Print. So we're going to have version 1, and we're going to print it from position I1 to position I1 plus L1. And we're going to do the same for version 2. And the chances are that we will see how, for some reason, we're including a dot in one of them. And it should be in the first one. Sorry, in the second one. So let's see what it does. Right, so what we see here, first we identify a 1 and a 1. That would be the first one. Then we read a 0, and a dot, which is probably this dot. But we don't know. So the next thing to print would be, I'm just going to add a little spacer here. And here I'm going to print the I1 and the L1. I1 and the, L2. Let's run that again. Right, so now we see here. So this is the character, and those are I1 and L1. I2, L2. So now here we start at position 2. So this is our I1, 0, 1, 2 at position 2. Length 1, which reads a 0. So this is correct. Here in this case, in the next case, we start to read from position 3 instead of position 2. So that means that we advanced the index I2 too much. So why could that be? Why did we advance? Oh, L1, L2, L1, L2. Okay, so it seems like there's a problem. So when we parse a number, why is I2 advancing too much? Let's see, the value of I2 is updated here with I2 next. It's I2 plus L2 plus 1. Okay, so we always add one more. What if we don't do that? would happen then? Do we then run into the problem revision substring length? I think it has to do with this one and with this one. We could remove this and just check, you know, if I1 or I2 are pointing to a dot, and if they are, we advance them. Maybe advance over dot, right? So if IDX is smaller than the length of the string and s at IDX is equal to a dot, IDX plus equals 1. Nice. IDX, well, next version 1, there we go, and the same for I2 and version 2. Let's see what that does. Okay. Shift and range L1. Revision substring length. This is still advancing too much. Yeah, so now you're in interview hell. It's not that difficult a problem, but you can't find the fucking bug. Congratulations, you don't have enough practice. That's essentially it. But we see that the range are the same. We don't see any modification of the indices here. That is fine. But I don't see how it advances across exactly onto the dot. That is slightly annoying to me. Plus L1. Maybe it's, you know, saying maybe is not a good thing in an interview. So if we reduce the +1 for when we want to emulate the 0, and so that way we make sure that we actually compute the real indices. But we could then say here just before a comparison, if L1 equals, well, we could say L1 equals max 1 L1 and the same for L2. So we do the correction for the missing revision number, where we want to place a 0 here just before you compare the lengths. Let's see what that does. So we're poking around now, something you shouldn't do in an interview. So we still have the same problem. And we should add a 1 here that we removed earlier. And still doing the same thing. Yeah, so nothing that we did actually changed anything. Skip leading zeros, maybe. Do we have an error here? Oh yeah, I think that's the error, because we're skipping leading zeros, but we're checking it against the length of the string. So, and what we should be doing is we should check it against the length of the revision substring, right? That's what we should do. So it's checking, so what's happening is it's checking. This is 0, yes. So let's skip over it because we're not at the end of the length, at the end of the string. That is the problem. That is the problem. So we have to check if the next index is unequal to a dot. That's what we need to do. And here we have to do a -1. Okay, so now we're getting a different error. That is fine. I cannot unpack a non-iterable int object. So we're returning maybe something somewhere. I1, I2. So what are the return values here? Okay, so here we're missing the next values. That's what the problem is. Do you have any others? No, I don't think so. So now we have the same problem again. IDX. Oh, I modified the wrong thing. I modified the wrong thing. And as IDX +1 is unequal to a dot. So we need to have at least 2 characters left in our string. Then we check that the current position is 0 and the next position is not a dot. All right, cool. That is cool. So I now wonder if we can change this back or not. I'll probably not try to submit it, and then we can see whether it works or not. My confidence is not very high, but let's give it a try. This is not part of debugging, right? So so now we have an edge case where we have a leading 0 and no dots. Right, so this is another edge case that we don't have here. So we check whether there's a dot. Yes. So this case does not cover that skipping of the leading zeros. So we should probably need another case for that, right? And that would be if the current character is a 0 and IDX +1 is still smaller than wait a second. Let me think about this. So this while loop would never execute simply because of this condition, right? Can we put that into the condition of the while loop to treat those as well? So yeah, I mean, you can see that my design, I think it's too complex. And that is why now we have to fix simple problems like this and try to incorporate them into these edge cases. So it would be nice to review the actual solution later to see how it went all wrong. and then we can learn from that and to see how we can make it simpler. Skip leading zeros. So skip leading zeros must support the case where we're in the last revision substring, so there are no dots following. And like that. Or the other case is idx smaller than the length of a string -1. And we have a 0 at the current position. Right. No. All right, so at this point, it's safe to conclude that, okay, you failed the interview. It's not working out. So what I would do now is I would actually look at a solution. So why not do this? Let's look at a solution. We saw earlier something O of 1. Yeah, let's go here. Nice. O of 1 space, 2 pointers, and has a Python version as well. So let's have a quick look. See how simpler this code is? Let's see. So what is the idea? Have a pointer for each version, plus the revision, you walk through the array. Each revision after pointers beyond the string length is naturally a 0, blah, blah, blah. Pointer +1, since you want to skip reading any revision separators. Yes, break out of loop when both pointers have reached their respective ends. Next revision always get inline, no need to inline manual, blah, 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 blah. Complexity, length of the strings combined. Okay. At least we had that part correct earlier. And so let's see. So it has 2 pointers. I call them I1 and I2. And yeah, it just has the same idea that we have. So let's see. And it just gets the value of the revision. Yeah. So this is what I suggested earlier, where you build the revision string as a number. But that means it's not O of 1 anymore, because the only reason why it's O of 1 is because we know that each revision substring fits into a 32-bit number. That's the only reason why. But in theory, they could be arbitrarily long, and then building this number is actually logarithmic in the length of how long the revision number is. So it's a little bit cheating, but also not cheating. But yeah, so it does that. So it just builds up the next number until it reaches the end. And by default, the revision value is 0. Cool. That looks cool. So now I've looked at the answer, and I'm just going to redo it and try to implement that thing from memory. And I have not looked at this before, so let's just try this out. So I1, I2 equals 0, while I1 is smaller length of version 1, or I2 is smaller than length of version 2. That's why that's in this while loop we want to advance our pointers to skip over the separators. And let's see. And we're going to have a little helper function, get revision value. And we're going to pass an index and an S. And we'll fill that out in a little bit. And yes, so we get a value 1. Get revision value I1 version 1. And we have the same for the second one. Cool. And now what we will do is we will do the comparison here, right? If L1 smaller than L2, we will return the -1, like here. And if the other case, we'll just return the +1. And now, otherwise, we didn't find anything. We'll just advance our pointers. And of course, we need to get the pointer, the updated pointers back from our thing. So, so we need to return the pointer and the comparison value here. While idx smaller the length of the string and s at position idx is unequal to a separator. We're going to advance this and we're going to build up the value. And we're going to use the integer value of the string at position idx, right? And before we do that, we have to left shift the number. So for example, if we have the number 1, 2, 3, and the first time value will be value is going to be equal to 1, because first it's 0, so 0 times 10 is 0. Then we add 1, so value is 1. The second time we go about it, what we do is we multiply this 1 by 10 and add 2. And then we multiply this value by 10 and add 3. And what you get is you get 10 plus 2 times 10 plus 3, which is, well, 12 times 10 plus 3, which is exactly 123. Right, so this is how you build up this number with the value. And yeah, so we're just going to return that here. Easy peasy lemon squeezy. So yeah, and this is nice because it avoids dealing with all of these edge cases. And yeah, we could even put that in here, just increment it here. We don't have to do it there. Let's run this. Submit it. And we're done. So yeah, there you go. So much simpler, so much better. But yeah, so this was an example of how you can fail at a coding interview when you make your code too complex. The idea of modularizing code was good, but didn't really work well here at all. And so for me, the learning from this is don't be shy to build up numbers, even if you want to have constant space. We should add that here, n equals length version 1 plus length version 2. And here we're doing a little bit of trickery. This is really log 10 of length of version 1, potentially, right? It's not actually really constant. So if you wanted to make it really constant, you would have to assume that these, well, you have to assume that this holds, right? That any provision number has a fixed maximum value. Then you could claim that it's actually constant space. Yeah, so anyways, yeah, I think I'm going to keep that recording. I think it's a good example of how things can go wrong. When they do, you will typically get feedback from the interviewer, or you can ask your interviewer, am I on the right track? That's also a good thing to do, by the way. You know, when you present your solution, ask them, do you think I'm on the right track? Would you like me to implement it? And typically you can read your interview and it says, you know that you're not on the right track and maybe you should look at the problem again if you can make it more simple. What got me caught up was to really try to get it to O of 1 space, assuming that this is not true. Because typically in Leetcode problems you get like these constraints, right? Here the length is fixed. Technically speaking, this is O of 1 time as well. because there's a maximum number of elements in the strings. But Leetcode adds them for practical purposes so that they can actually run the code on a computer system. But for an asymptotic complexity analysis, that's not typically the case. Yeah. So that was a good one. I hope you find this video useful. Yeah, and things can go wrong. That's okay, as long as you learn from it.